In this video, I'm going to go over the practice PAT for electricity. You've heard me say it, so make sure you do the practice PAT and then come back to the video to watch and double check any of the questions you didn't get correct. So with that, let's start with question number 1. Okay, number 1. So it says here, clothes that are removed from a clothes dryer are sometimes stuck together. The example described above is most likely a result of the following. So current electricity, build-up of neutral atoms, an imbalance of electrical charges, anti-static sheets absorbing neutral charges. So what we're asking here is, we know this, when we pull clothes out from a dryer, it does get stuck together sometimes. And what that is that static electricity. Same thing happens when you take like a balloon if you were to rub it over your hair. So because it's static electricity, what it's asking here is the definition of that. So the definition of static electricity is an imbalance of electrical charges. So the answer for this one is going to be C. Okay, number 2. So with number 2, they're asking, Joe watches television for 6 hours or 21,600 seconds. The input rating of his television is 200 watts. So we want to know what's the total electrical energy consumed during this time. So notice how it said just the time, so for the 6 hours or the seconds. So what I did is I wrote out our formula here. So we know energy is equal to the power in watts times the time in seconds. So that means what we need to do is multiply these two numbers together. When I do that, I'm going to get my answer as D. Okay, number 3. So we've got some information here. It says here, a garage is equipped with 2 lights and a power source. Each light can be controlled separately. And there is a switch that can turn off both lights at once. So that's going to be really important. So the first thing I know is right away there's going to be 3 switches, 2 bulbs, and of course a power adapter. So looking at our options, right away I'm going to cross off A and D. And the reason for that is those have 2 switches, but we know we have 3 switches. Now the second thing I need to pay attention to is the last statement here. There is a switch that can turn off both lights at once. So what that means is I'm looking for a place in the circuit where once I open the switch or I disrupt the circuit, both lights will go off. So if I look at option B, what happens is, let's say these circuits were closed. That switch is on, meaning power can go from here to here. What I notice is if this is closed, that could work, right? Because it would go like this, electricity could go through here and here. But it means that in order for electricity to run to these bulbs, this has to be closed at the same time. So I'm a little concerned about that one because I don't remember that being in the statement. Whereas I look at C, if I were to close these circuits here or like turn on the switch, however you want to say it, that's going to allow this bulb to light up. And it says our third switch, once it's open, turns off both separately. Well, this one really does that. If this is open, then we know electricity cannot flow, and that's going to stop the flow of these 2 here. So our answer for this one is going to be C. Okay, number 4. So they gave us this table up here. So let's go through and highlight a couple of things. So the first thing is the year. The second thing is the type of energy. So coal, I know, is non-renewable. Natural gas is non-renewable. Hydro is renewable. Same thing with wind. And biomass and waste, that's also going to be renewable. So with that, what we need to do is decide which of the following statements is supported by the information in the table above. So one thing that I'm noticing, just kind of right off the bat, is we did start to use, or they started to use more coal. But I also noticed same thing with natural gas. And then when I'm looking at our renewable resources, this does start to increase just as much. So let's read the statements and see which one applies. So A says the combined production of energy from renewable and non-renewable resources decreases. Well, we know that's not true. They obviously increase, which then makes me look at B, and I think that this one would work because everything does start to increase as we go from the year 1999 to 2002. C says as the generation of electrical energy from non-renewable resources increases, the generation of electrical energy from renewable resources decreases. Again, that wasn't happening. We did see that this was increasing and this was increasing. So I wouldn't say that that would support the information. Our final one says, as the generation of electrical energy from renewable resources increases, the generation of electrical energy from non-renewable resources decreases. Again, that doesn't fit because we know that this goes up, this goes up, this goes up. It's only looks like the wind really goes down. Everything else continues to increase. So our answer for this one is going to be B. Okay, number 5. So with this one, we want to know which of the following electrical chemical cells would produce the highest voltage. So for this one, we need to be really clear of what an electrochemical cell is.
Basically a battery. Well, almost. Our picture is a little bit different here. But essentially, we've got our electrodes, which are the metals that are going to help generate a current. So there's a lot more chemistry involved in this. I'm just going to give you the simple one. Basically, we are creating a battery really similar to the battery you might have had when you were kids. With those batteries, you have a positive and a negative end, and that's going to allow the electrons to flow through, generating a current that can power the toy. In this example, same idea, we're just not powering a toy, we're measuring the voltage.
An electrochemical cell allows a current to be generated between two metals of opposing charges. So the first thing I'm noticing with all these options is we have option A and B, and they contain the same metals. That's not going to work. They have to be opposing metals that are going to allow the electrons to travel from one metal to another. That's going to generate the circuit. So A and B are not going to work. Looking at option D and C, I like them. We know we've got two different electrodes. We've got our zinc and our copper. However, we need to be mindful of the solution. So the solution that's actually going to allow for electrons to be moved through is actually going to be an acid. So for this one, our answer is going to be D. Okay, numerical response number 1 here. In order to produce 100,000 joules of heat energy, a hot plate consumes 800,000 joules of energy, and we want to know the percent of this. So for this one, we really just need to know how to create a percent. So we're going to take our input and our output. So our input is going to be 800,000, and our output, so our input is going to be 800,000 and our output is 100,000. To figure out how efficient this is going to be, we'll divide those two numbers and times it by 100. This one, honestly, like a little bit of a math lesson, we can really just knock off the zeros here. And we can say, well, okay, it's really going to be 1 out of 8, which is 0.125 as a decimal. Multiply that by 100. That's going to get me to 12.5%. So that's our answer. Okay, number 6. So with number 6, we have a circuit with 3 identical bulbs. And the only thing that I noticed here that's interesting is they added a resistor. So I'm going to go under the assumption that the resistor is turned on. So if we remember, a resistor slows down the flow of electrons. So what this does is it can dim the light. Okay, so we probably have this on like ring lights, on our phones we have it, smart bulbs have it. Essentially, you're reducing the flow of electrons and that's going to dim the bulb. So the other thing I noticed is we have what's called a parallel circuit. This means the electricity can flow to each bulb, and if everything is good to go, it's going to give an equal amount of brightness to the light. So what I'm going to do here for our reference is I'm going to say this bulb is going to be bright, but it's not going to be as bright as the other two because the resistor is being applied. So this bulb would be really bright and this bulb would be the same amount of brightness, again, if everything's working correctly. So our job for number 6 is to figure out which of the following statements predicts the relative brightness of each of the 3 light bulbs in the circuit. So the first option says number 1 is brighter than 2. Well, we know that's not going to be true because we're applying the resistor. The second one says number 1 is dimmer than 2, which is dimmer than 3. So that could be the case. However, it's a parallel. So 2 and 3 should have the same amount of brightness, so that won't work. C says the bulb 1 is brighter. That's not going to work. That's going to leave us with option D. So again, let's verify that. So light bulb 1 is dimmer than light bulb 2 and 3, which both have the same brightness. That one is definitely going to work. So our answer is D. Okay, number 7. So we've got the following information about a circuit. We know it contains one light bulb. It draws a current of 3 amps, has 2 wires, and connects a 6-volt battery. We want to know the resistance. So what I did is I pulled up this formula here. I'm going to show you all just using the pyramid because most grade 9s like that. I just want to kind of say my math piece here that it is important to know how to rearrange these formulas, especially as we move forward in math in high school and in science in high school, believe it or not. But for now, just for this video, just for practice, I'm going to use the pyramid. So what we want to do is we want to calculate the resistance. So we know resistance is R. So basically what I'm going to do is I'm going to cover this up and I'm going to see what am I left with. Well, I'm left with V over I. That means to calculate resistance, I'll take my voltage and divide it by my current. So my voltage in this case is 6. We got that from right here. And our current is 3. So 6 divided by 3 is going to give me 2. So our answer is going to be A. Okay, number 8. So tungsten is a poor conductor used as a filament in some light bulbs because tungsten blank. So really what they're asking us is, do you know what a poor conductor is? So a poor conductor means electrons can flow, but they kind of struggle a little bit. They've got a little bit of a resistance going on. So that means the only option for this one that's actually going to work is going to be C, where it is going to resist the flow of electrons. Okay, number 9, we want to know which of the components in the circuit will be turned on when switch 1 is closed. So what I'm going to do is I'm just going to go through and highlight this. So let's say switch 1 is on. That means this circuit would be connected. And that means the flow of electrons can go through the power source, through our light. It will, because this is a parallel circuit, it will go through the furnace. And this whole circuit would be complete, right? Because it would go just like that, right? It'll keep going around. But also because it's a parallel circuit, it's also going to go through here and it's going to hit the doorbell and then keep going. Now the main reason it will not hit switch 2 in the exhaust fan is because this switch is going to remain open. There's nothing here that tells us switch 2 is turned on. So that means for this option, in figuring out which components will be turned on, well, we know that we're going to have our furnace motor. We know we'll have the light bulb, so we can cross off these options. And then the last one is just going to be our doorbell. So our answer for this one is B. Okay, number 10. So with number 10, they gave us some examples of electricity, but our job is to describe which ones would be static electricity. So if you don't remember what static electricity, this is the definition. It's basically unbalanced charges. And I'll also leave a video in the description that you can watch that fully goes through and describes what static electricity is. So we need to decide out of these options, which one would result in an unbalanced set of charges. So for sure, option A, I talked about that earlier, rubbing a balloon. In this case, it's not on your hair, but it's with wool. That's gonna make the balloon stick to the wall. That's static electricity. Option 2 says conducting a battery in a circuit can turn a light bulb on. That's great, but that's not really static. That's just the normal flow of electrons. Option 3 says plugging a cell phone into an electrical outlet will charge the phone. Again, that's just our basic kind of electricity. Option 4 says using conditioner can help prevent the buildup of electrical charges in hair. That one is definitely true. So to all my people with long hair, when you do have static hair or frizzy hair, conditioner does help. The other one that I kind of want to mention is funny is if you do have like static hair, you actually can use a dryer sheet because a dryer sheet has the opposite charge, so it's able to absorb the unbalanced charges and make your hair not as staticky. So our answer for this one is going to be options 2 and 4, which is letter D. Okay, number 11. So we have an electrical storage cell, and it says here, Ali noticed that no electricity was being produced. And we can see that right here. We want to know which change could Ali make to the electrical storage cell to produce electricity. So we kind of talked about this before. We know we need acid, so our acid is pretty good. That means we're probably not going to want to change that. But we also know in order to actually start to generate the movement of electrons, we need two different types of metals. So that means instantly we're going to need to replace this metal with something else. That leaves us with option A and C. No, forget that. It actually leaves us with only option A. Sorry, because it says replace one of the zinc electrodes with copper. That would work. If we replace both of them with copper, we would end up in the same situation here. So our answer for this one is going to be A. Number 12. So number 12 wants to know which of the following conditions of a circuit would be expected to cause the light bulbs to shine brightest. So looking at our options here, one of the things I noticed is they do mention a resistor. So we know a resistor is going to slow down the flow of electrons. That means it's going to make our light bulb dim. So anything that says to have a resistor is not going to work. So then that leaves us with these two options. And where we need to look at is the number of bulbs. So they haven't indicated if this circuit is parallel or series, but what we do know is if we add more bulbs, and let's assume it's a series circuit, if we add more bulbs, that's going to decrease the brightness, right? So that means our only option that's going to work for this is going to be C. Number 13, a student explains how electrical circuits function by comparing them to traffic models. Some of the components are listed below. So they have a speed limit sign, traffic lights, vehicles, and roads. And we want to know the one that's most closely related to representing a switch. So we know with a switch, we're going to start or stop the flow of electrons. So if we think about this, the only one that's going to be a good analogy is going to be our traffic lights. We're going to stop or start the flow of cars, or in this case, electrons. Numerical response number 2 here. So this one is an interesting one. It says here, Kelly recorded the input and output energy of 4 electrical devices. We want to order them from most efficient to least efficient. So one thing we need to remember is we need to figure out the efficiency of it as basically input over output. So 3 over 10, that's going to be 30%. And just so we're clear, the way I'm getting that is I'm saying 3 over 100 would be 0.3 times that, 3 over 10, sorry, times that by 100 would be 30%. 72, the closest I can get would be about 22%. For number 3, it's out of 100, so that would be 27%. And for our last one, this is only 50 joules away from being 1,000. And this one is pretty close to being right in the middle. So for this one, I'm gonna say it's roughly about 50%. So now we have to decide which one is most efficient. So in order for something to be efficient, it has to have the highest percentage. So our highest percentage is going to be 4. Our next one is going to be 1. Then leaving us with device 2 and 3. So 2 is going to be our lowest and 3 is going to be our second least efficient one. So our answer for this is going to be 4, 1, 3, 2. Okay, number 14, we want to know which of the following is classified as renewable, a renewable source of energy. So the only one that's going to work, that's going to be renewable, is going to be our biomass. And I talked about that in our previous question. So I've officially gone through all the practice PATs, and I'm looking at this question, and again, it's talking about the manipulated variable. So I'm not sure what order you're watching this in, but again, I'm going to use my same analogy. So a manipulated variable, when we think of manipulation, we're basically saying we're kind of changing how someone would think. So with a manipulated variable, we are looking at what is changing, and we actually need to use the information above. So when we think about what's changing, this is the outcome of what we're changing, which is the device. We're using different devices and measuring their efficiency. So in this case here, our answer is going to be D, the type of device. Number 16 here. So with number 16, they have given us our voltage and our current. What we need to do is to figure out the power of the light bulb. So with this, I did pull up the formula. So in order to figure out power, we need to multiply these two numbers together And again, I'm just gonna say my reminder, I think right now, to keep it nice and simple, we can use that pyramid. Just remember next year, with both math and science, formulas get a little bit more complicated, so we need to know how to rearrange them. But for now, we can take our 9 volts and multiply it by 4.4. That's gonna leave us with option D as our answer. Number 17, so with this one, we want to know which of the following statements describes a disadvantage of coal-fired electricity. So with this one, we kind of just need to spend some time and make sure we know about our energy production. So first thing I know is coal is non-renewable, and we are burning it for it to provide energy. So because we are going to be burning it, it does emit a lot of pollutants into the atmosphere. So the answer for this one is going to be A. Okay, everyone, I just want to say congratulations, you are on your last question. And if this is the last video you've been working through, then this is over. This is done. Isn't that exciting? Okay, let's go ahead and let's look at number 18. Number 18, we want to know an electrical device with low efficiency is most likely producing what kind of waste. So we kind of know this already with our devices. A lot of the times when we use our laptops over a long period of time, they do produce thermal energy. We also know this of certain light bulbs. If they're not the LED ones, if they're the kind of old school ones, they do produce a lot of heat. You can actually feel around it and it'll be quite warm. In fact, as a kid, we actually used it for baking. So basically we need an option that says it's going to produce a lot of heat. So the option for that would work is going to be option B, thermal energy. So I hope that was helpful. Good luck studying for those PATs. And just as a reminder, in the description, I've got some interactive tools to help your learning. And I do offer those one-on-one sessions to help you. That's not just for grade 9, but also when you all are in high school. So good luck, everybody, and I'll see you all in the next one.